All right, welcome to Module 1.2. We're going to be talking about soil formation. So some of the things we want to talk about here are going to just kind of have an understanding of like three different rock types and kind of also go over the rock cycle and some of the processes because those are really going to form the foundation of our soils because that's kind of like the parent material. We'll talk about the five different soil forming factors. We'll identify some of those parent materials and then talk about the four different soil forming processes. And so there's two separate things here. We have the factors and the processes, and you'll be able to see these as we go through this module. So as we talked about, you remember the pie chart from the previous module. We have these minerals, and the minerals are the things that the rocks are made of. Like there's a chemical structure and an equation for every for every rock that is out there. Now, there may be a lot of different minerals within a rock, but the rock is what's going to break down. That is what's going to we talk about the bedrock, and so that is where that soil is going to form from. There are these inorganic substances and they have this definite and predictable chemical composition and physical properties. And so we talk about the way that a mineral breaks, or maybe it has some streak or a hardness. And we'll talk about that in just a moment. So we have these three types of rocks. We have igneous, sedimentary, and metamorphic. And so you probably heard these terms before. It might have been a while, maybe middle school kind of physical science or maybe from a geology class of some sort. But these are kind of the, that are part of the Earth's crust. They are the basis of when our rocks break down. And when those rocks break down, they release those minerals. And within inside of those minerals, that is where we get C. Hopkins Cafe, managed by my cousin Mokul Nina. They are contained within these minerals. And those minerals make up the rocks. So some of those other rock forming minerals, and you don't really need to be, too hyper focused on this thing. Quartz. Quartz is going to be like sand. We have muscovite, biotite. We have muscovite there again. These are going to be kind of some of the things that you can see in these soils, in these feldspars. So as far as like the mineral formation, we had the difference between magma and lava. And so magma is going to be that molten rock underneath the surface. So while it's still in the Earth's surface, it is still magma. Now, once it comes out of the volcano, it is then lava. And so when that lava hardens, cools and hardens, that's when we start to have the mineral formation. Because, kind of, if you can think about lava, there's really like no kind of structure to that, right? It's all molten. And so once that cools, it will then form different types of rocks based on the minerals that are in it. And so that is going to be influenced by temperature, pressure, and time. Those three things. How hot is it? Is it going to be compacted? And then how long did it take? Actually, this time thing is how long did it take to cool? And that is going to influence the actual formation and structure of those igneous or sedimentary or metamorphic rocks. So just kind of showing this Bowen's reaction series. Here are some of the minerals that I mentioned before. And we can see that as the temperature decreases, when we start to have this different formation of these minerals. And so remember that we talked about a mineral has these specific chemical composition and also physical attributes that we can kind of determine what the mineral is. And so because of Bowen's reaction series, we know that olivine has a specific temperature of melt. It cools down at a specific rate. It contains certain chemicals or certain minerals that make it olivine. Mohs hardness scale is one that we use. And so many of us might be familiar with, they say that it takes a diamond to cut glass. And so you would have a diamond, and glass is technically made out of quartz. So that's why, only corundum or maybe topaz would be strong enough to cut quartz. I look down here at talc. Any of you ever, I don't know, like baby powder? Baby powder is what they make, is made from talc. It's a very soft mineral. It would not be able to scratch glass. So this is where we talk about the hardness scale of that. So we would be able to use our fingernail to make an indentation in maybe a ball of talc, but we would not be able to make an indentation on a knife, right? So each of these minerals have this hardness that we can identify. And once we can identify the hardness scale, we can identify the mineral. And when we talk about the rock cycle, this is kind of the formation from beginning to end on how these different rocks form. So remember, we have magma that is inside of the Earth's surface. Once that magma exits the volcano, it is then as lava and undergoes cooling and crystallization. Cooling and crystallization to form the igneous rock. So from magma to igneous, we need that cooling and crystallization. So we can either have extrusive igneous rocks or intrusive. So we have magma that forms a rock underneath the Earth's surface for intrusive. So extrusive is obviously going to be external. So once that lava comes out, it is then cooled and undergoes the crystallization to form that igneous rock. So we have these different igneous rocks. As I mentioned, we have extrusive and intrusive. This isn't really a mineralogy class, but just to give you an idea that ultimately this rock will undergo weathering processes. This basalt will undergo a weathering process. And when this kind of degrades and erodes and, water hits it enough, some of these chemicals and minerals will be, broken off and chipped and decomposed and then released into kind of the material that is there. So this is where we're going to get the minerals that are in our soils. Granite, probably not going to see a lot of granite because we use that for countertops. So it has a very hard composition to it. It doesn't break down very easily. Next, we have our feldspars. We have a felsic, which is feldspar and silica. That's where we get felsic from. Or maybe it's mafic, where we have magnesium and iron in this. Next, we have sediments or sedimentary. So once this igneous rock undergoes some weathering processes and possibly some erosions, we'll get some sedimentation. So erosion is the moving of the material from one place to the next. Maybe it's even wind erosion. So we had this gust of wind that picks up some sediment off the Earth's surface and moves it somewhere else. So within these sediments, there is the process of lithification. You might have seen this before when we talked about the lithosphere. So this is going to be like the actual physical part of the Earth's soil. that makes up these rocks. This lithification is ultimately going to be kind of where we get the parent material from. So within lithification, there are 3 different processes. So that as those sediments are moved to a location, we have compaction. So it's kind of like, maybe an animal moves across it and kind of presses that mineral into the next one, or maybe even the weight of multiple depositions causes us some compaction. Next, once it's compacted, we have cementation. So this is where that rock actually kind of forms together. So cementation, and then finally more crystallization. So the 3 components of lithification are compaction, cementation, and then crystallization. This forms our sedimentary rocks. So sedimentary rocks are technically formed from igneous rocks. Oh. So as I mentioned, compaction, this is going to be laid down, and as the mass becomes greater, we start to get some compaction, and that is going to form layers. We will get some chemical deposits that move into those kind of in between those like open voids or pore spaces and kind of cement those particles together. Once they're all cemented together, there will be this crystallization of those minerals. Many of us have seen things like this out in the Midwest. It's just sediments, man. They're just laid down layer by layer by layer. And so you can start to see that it started out here, and that as we put more layers down, that we had this sedimentation, and then finally those were cemented together, and they probably actually have a crystalline structure inside of those. An interesting thing is that it's not always this kind of sedimentation where it's layer on top of layer on top of layer, but it might be something more like we just have a group of minerals or rocks that fall close to each other. There is some cementation, and then we get a crystallization. So it doesn't always have to be this kind of falling on top of each other. It can really also be like a conglomeration. Just to kind of show you a couple of the different types of sedimentary rocks. So we might have clastic, and so that's kind of what we have here, this clastic rock. And it's got some calcite and some quartz in it, and these may or may not break down. It might take a lot in order to break that down. Limestone is something that you'll probably see a lot of. Obviously, limestone is going to be this calcium carbonate. That's where we get our liming material from. We probably use this probably the most out of between clastic and chemical sedimentary. Like this is the one that you'll probably encounter the most. And then we have organic sedimentary. And so this is kind of the layering of plants. Those plants decompose and grow year after year. They fall over and die each year. So we have this layering or this sedimentation of plant material. And then we have another growth of plants that lay on top of that. And we continue to put layer after layer of plants. Those plants become heavy, start to compact that soil. We get some cementation, and then this gets buried very quickly. And so we mine this out of the soil in order to combust it for our energy. So this has been altered both physically and chemically. It undergoes some of this decay. Here we have our time, our pressure, and our heat. And this kind of shows you where this started out in the beginning, that this peat and the sediment will end up basically being compacted to form our coal. And so this is where we get our charcoal from. In waterlogged environments, that debris gets accumulated, and we have those peat bogs. So finally, going back to our rock cycle, the next one, the sedimentary rock will undergo pressure and heating, as we just saw with our coal. And that pressure and that heating, that is a metamorphic rock. So ultimately, we started from igneous rocks, and igneous rocks can also undergo a metamorphosis. If you had an igneous rock that underwent heating and pressure, we would get a change in the chemical structure of that rock. Then finally, all of these rocks are subject to melting and can be then formed back into magma. And so, kind of the underlying premise of the rock cycle is that it happens kind of in the earth and it can happen outside of the earth. So, I wouldn't expect for a metamorphic rock that was on the earth's surface to melt and then turn back into magma. But if you can think about billions of years ago when the earth was forming, these are kind of the basic principles or the basic processes that formed the crust of the earth's surface. And so metamorphic, we can have this shale that ends up being, undergoes this pressure and this temperature to form things like gneiss or migmatite. And again, this isn't a mineralogy class, but these are kind of the basics of how we get our soils. All right, so moving on to soil formation, we have the 5 soil forming factors. Right, these are going to be the forming factors. Later on, I'm going to talk to you about the soil forming processes, and these soil forming processes ultimately give us the soil physical and chemical properties. So later we will classify those. So we kind of talked about an introduction, and that we have these minerals that are essential for plant nutrients. We know that those minerals are parts of rocks. We talked about how those rocks are formed. Now we're going to talk about some of the things about the formation of the actual soil, the processes, the physical and chemical properties, and then also ultimately we'll finish up with the classification. That is the culmination of everything that we've talked about here. So the first thing is the parent material. And the parent material is kind of like the base rock that it was formed from. Next, we have the climate. So, as I mentioned before, with the determining the ecosystems, those climates actually impacted how that soil formed or possibly didn't form. We have organisms, and that's why those organisms are so important because they are going to change a couple of things. They're going to decompose some plant material. They're going to possibly burrow through some of the soil that has started to form, and that's going to add some oxygen, which is going to change that decomposition and restructuring. Next, the topography. The topography is just the elevation or the slope or kind of the lay of the land. Um, One of the things that I've noticed here in Tennessee as to why we have such shallow soils is because we have a lot of erosion. We have, if you go on top of, I guess when I'm thinking about this, I'm thinking maybe on the top of a hill. And what comes to my mind is if you've been to Cookeville, if you get on I-40 and you make a left onto 111, you can look and see that quarry, that rock face, and I'll show you this in a moment in a picture. Uh, all of the soil that is in the bottom came from the soil on the top of the mountain. So topography is going to have an influence on how that soil was formed, and then it's going to take time. Soil doesn't form overnight. It is a very extensive process in order to get a very deep soil formed. So remember, these are the soil forming factors. And what I want to look at in this next slide is the time. So this is kind of a timeline of how the soil forms. This is not the soil forming factor. This is the timeline, the process of the soil formation. So we have our igneous or maybe our sedimentary or even our metamorphic rocks that serve as this bedrock. Maybe we get an animal that comes by and and when I'm thinking about this, like maybe a deer, right, that has a hoof that kind of breaks apart this piece of rock, or maybe it undergoes some weathering process where um, there's a pore space, or maybe that some of the rock might even kind of expand and allow some water to get in there, and then it freezes. And that when that water freezes, it expands and breaks a piece of the soil off. And so, if we were in class, you could see that I'm doing this very small movement with my hands, where there's this slight expansion, and when that slight expansion happens, you're going to get something that breaks. And when that piece breaks off, or maybe you got a plant. Um, you can start to see that we're getting this pore space, and that allows roots to grow. Once we get our roots growing and our plant populations moving, um, we can start to increase root growth. And as those roots grow, it's going to break apart that rock a little bit better. As we get more organic material, we start to get things layered down. So soil actually forms from the top up. Like it doesn't, like this is the bottom, this is the base. So you can see that here. Everything happened on top of that soil. And actually, the soil got taller, if you can think about it. But when you hear this, we talk about a very deep soil, but it actually formed from the top because we're laying more soil on top of it. And so, one of the things that we say when we talk about a PhD stands for piled higher and deeper. So everything gets piled higher and deeper on top of this bedrock, and that's how we get deep soils, by the continuous formation or maybe even the deposition of those soils.